Hello everyone. In this video, we'll be solving problem 3021, Alice and Bob playing flower game. The problem statement is about a turn-based game that is played between Alice and Bob. Both players will take turn to pluck a flower from two lanes and the player who picks the last one wins. The problem statement is asking us to calculate what possible combinations of flowers could be between a certain range in the two lanes which can guarantee Alice's victory. This is a short summary of the problem statement. You can read through the details to get a better idea. There are few rules and conditions given to us. The most important one is each player can pick a single flower from each of the lane and the player who picks the last one wins. Now let's switch to whiteboard and discuss how we can solve this problem efficiently. Let's break this problem down into smaller pieces. Starting with understanding how will Alice comfortably win every time. Because there are two lanes given to us, X and Y, with some number of flowers, and each player will take turn to pick a flower from either of the two lanes. As the player who picks the last flower wins, we need to make sure that Alice is the one who gets to do that. So we are looking for the total number of flowers between X and Y, which will give us the confidence that Alice will always be picking the last flower, making her the winner. I hope this part was clear. Now, even though we have two lanes, X and Y, and the player needs to pick flowers from either of the two, it does not matter how many flowers are there on each of the range. Right now, we should be focusing on the total number of flowers between the two lanes that can guarantee Alice picks the last one. As this is a two-player game where each player gets their turn, the only way Alice can get the last flower or the last turn is if we have a total of odd flowers across the two lanes. Let's take a short example where we have a total flowers of 3. If Alice takes the first one, the remaining will be 2. Bob goes next, the remaining is 1. In Alice's next turn, she picks the last flower, making her the winner. As we know for sure that Alice is always going to start first when the game begins, we can be certain that odd number of flowers will always ensure her victory. If we had even number of flowers, then Bob will be the one picking the last flower, making him the winner. As we need to identify the possible number of pairs between X and Y whose sum will be odd, let's discuss if there is a pattern to determine that. To get an odd sum between two numbers, let's say x1 and y1, either of the two should be even and the other should be an odd. One number being an odd while other being the even number is the only way to get an odd sum. Based on this theory, we need to determine possible combinations of odd numbers in X and pair it with even numbers in Y and added with the same combination but just reverse the requirements, that is even number in X and odd numbers in Y. Let's do a short dry run to understand this approach better. With X is equals to 3, there are total of 3 odd numbers, 1 and 3, while even number is only 1. And on the other side, with Y is equals to 2, we only have one odd number, which is 1, and one even number, that is 2. As the pairing is between the X odd with Y even, the total combination is to multiply the count of each of them. On X odd, we have 2, and Y even is 1. Between these two values, we can expect two pairs to get the total as odd number. The pairs will be 1, 2 or 3, 2. Now we'll add this total to the other combination where we are taking the even number from X and odd numbers from Y. With these input, the total number of combinations is 3, where we can ensure Alice will win every time. Here's the mathematical formula to determine the output. This is based on the explanation that we just went through. With this solution, our time complexity is O of 1, as we can simply use the division operation to calculate how many even and odd numbers are there in X and Y and then use the formula to calculate the pairs. As we don't need to run any iteration on X and Y, the time complexity is constant time, that is O of 1. While the space complexity is also O of 1, that is constant space, as we are using few variables to record the X and Y odd and even numbers. I hope you are able to understand this explanation. Let me show you how we can implement this using C#. In this C-sharp implementation, I start by calculating the odd and even numbers in the x range by applying the formula that we discussed. For odd, I am doing n plus 1 divided by 2, and for even, it's simply n divided by 2. On the next line, I am repeating the same formula on m. After calculating individual values, I am multiplying x odd with y even and x even with y odd, and the product of the two combinations will be added to get the output. This code, when submitted on LeetCode, beats 100% of the submissions in terms of runtime and nearly 56% in terms of memory. Thank you for watching this video. I hope you are able to understand the explanation. The details to access the source code is available in the description below. Feel free to check that out, and I will see you in the next one. Thank you.